Have you ever thought of how the operations on decimals work or how you do them? For example, how would you do the problem 1 and 2600ths plus 2 and 45th hundredths? How do you add decimals? What's your procedure or algorithm? Well, to add decimals, we're going to do a base 10 blocks flashback. We're going to use the same manipulative we used with whole numbers, but this time the blocks will represent different values. The whole, or the unit, is going to be a flat. A rod or a long is going to be the tenths. The small cubes are going to be the hundredths. So use base 10 blocks to model both add-ins in the problem 1 and 2600ths plus 2 and 4500ths. Now write down all the steps, including pictures, to complete the problem. Here's an example. So step 1 is to model both add-ins. Since we're adding, we're going to join the blocks together, and then we're going to make the trades necessary. So we can trade 10 of the small cubes for 1 long, and then we can count everything together. So we should have a total of 3 and 81 hundredths. There's another way you can do this as well. You could add relating them to fractions. So if you rewrite 1 and 26 hundredths as 126 over 100 and 2 and 45 hundredths as 245 over 100, you can just simply add because they have a common denominator. So you would get 381 hundredths, which as a decimal would be written 3 with a decimal point and then an 8 and a 1, and we would read that as 3 and 81 hundredths. Or you could use mixed numbers and write it as 1 and 26 hundredths plus 2 and 45 hundredths. Add the whole numbers, so 1 plus 2 is 3. Add the fractions, so 26 over 100 plus 45 over 100 is 81 over 100. So you get 3 and 81 hundredths. Your traditional algorithm of lining up the decimal points really talks about place value, and we've always added by place value, but relating it in this way to base 10 blocks or to fractions allows students to really make sense of that. How about subtracting decimals? Let's take this problem, 2 and 45 hundredths minus 1 and 26 hundredths. Remember, when you do subtraction, you don't model both of the numbers in the problem. You only model the minuend, or the first number. Let's see an example. Alright, so here's the example. First you model the minuend, so 2 flats, 4 longs, and 5 of the small cubes. We need to take away 6 of the small cubes, but we don't have enough, so we're going to regroup 1 long as 10 of the small cubes. Now we can take away 1 flat, 2 longs, and 6 units, which was our subtrahend. Now we're just going to count the remaining blocks, and we get 1 flat, 1 long, and 9 units. So our answer must be 1 and 19 hundredths. We can do the same thing with subtracting, relating it to fractions. So if we write 245 hundredths minus 126 hundredths, we would get 119 hundredths, or 1 and 19 hundredths as a decimal. Or we could use our mixed numbers. 2 and 45 hundredths minus 1 and 26 hundredths equals 1 and 19 hundredths. So you can do it either way. Again, your traditional algorithm works, but you should be connecting the y's and really relating this to your whole number algorithm or your whole number procedure with base 10 blocks, and connecting it with fractions so you solidify that fraction understanding. I hope that helped with adding and subtracting decimals.